Okay, so in this video, we're going to continue talking about the IA, and in this video, we're going to talk about collecting data and uncertainties and graphing your data and stuff like that. Okay, and so just to start off with, we've already talked about this, but I just want to refresh your memory. When you're doing your IA, you should have a minimum of 6 data points. Okay, that means if you think in terms of like making your graph, you should at least have 6 different points on your graph. And of course, more is better because the more data points you have, the better chance you have of finding like a realistic relationship between your variables. Now, each data point should be found by performing the trial multiple times, at least 3 times, and then averaging your data together. Okay, and so averaging is a form of data processing, which is a required element of the analysis section. And we'll talk more about data processing later, but one example of data processing is averaging. Okay, let's see. I think that's basically everything I just said. And so if you look at the criteria presentation that's on Canvas, the example that they give is basically where they're doing an IA based off of seeing how the number of sheets of paper on the ground like affects the rebound height of a bouncy ball. Okay, and so notice here we have a very nice data table um, that's been created. So when you're making your data table, you have to make sure to include units on everything. You want to make sure that you include the uncertainties in each measurement. And this data table is actually very nicely formatted because we actually have the raw data here, and then we have the process data or the average data here. And so when I say process, I basically mean that we have made some type of like direct measurements, and then we've done some type of calculation or averaging, or we've done something to that data to get it into a different form. And so that's why I said averaging is a form of data processing. And so here what they've done is basically they've measured the rebound height of a ball 3 different times with 0 sheets of paper, 2 sheets of paper, 4 sheets of paper, 6 sheets of paper, and 8 sheets of paper. And so the number of sheets of paper is their independent variable. Notice how they specify everything very clearly in this data table. I know exactly what it is I'm looking at. I know that there's no uncertainty in this measurement because, well, there shouldn't be uncertainty in how many pieces of paper there are. In the rebound height, I want you to pay attention to how the units are included. Not being in SI units is fine as long as you're in some type of unit that makes sense. And so rebound height in centimeters makes sense here because the height is relatively small. Also notice that the uncertainty is given as plus or minus 0.2 centimeters. Now, depending on what it is you're doing, you are responsible for arriving at the uncertainty in your individual measurements. Okay, and so that's based off of your perception of the measurements. How are you making the measurements? Because remember, when you record the uncertainty, you're basically telling the person reading it how sure you are about your results. And so that when you say plus or minus 0.2 centimeters, you're basically saying that this is the height, but I could be off by as much as 0.2 centimeters. And so part of that judgment is going to be based off of um, the equipment you have available, and also some of it is going to be based off of your personal preference. And so it's really up to you what uncertainty you choose, but you need to justify it when you're writing out your exploration piece. You need to say like the uncertainty I'm using is this because X, Y, Z. Okay, notice that they have the values for each of the trials. Also notice that the decimal place, there's one decimal place here, and all these measured values has the same number of decimal places. Okay, one of the basic tenets of uncertainty is that the uncertainty has to have the exact same number of decimal places as your measured value. Okay, so all of these measured values have exactly one decimal place. So when you do your data table, you need to make sure that you format it correctly so that the uncertainty decimal place matches your measured value. Now, I will say, if you, let's say you have an uncertainty of plus or minus, let's say 0.05, and your measured values all have a 0 at the end of them, then it's possible that you did not choose a realistic um, uncertainty. Okay, or it's possible that you made mistakes with the measurements. Remember, if you're making a measurement with a non-digital device, you should be estimating the last decimal place, and so that uncertainty should be realistic. Now, I also want to point out that in the right column, we have the average values of the height, and notice that the uncertainty here is not the same as the uncertainty here, because this plus or minus 0.2 comes from the uncertainty in the measuring device and also the uncertainty that the person made in the individual measurements. The plus or minus 2.0 comes from the half range method, because when you're talking about the uncertainty in an average value, that's where you use the half range method. And remember, the half range method is basically range is the maximum value minus minimum value. And so the half range method means you take the max value minus the min value, divide by 2. Now, people always do this wrong, so let me be very, very clear what I mean. When I say the maximum value, I minus minimum value, I don't mean the highest value overall minus the lowest value overall, which would be this one. It does not make sense to do 55.1 minus 44.6 divided by 2. That doesn't make any sense. Why does that not make any sense? Because this measurement goes with this um, independent variable, okay, 0 sheets. This measurement goes with this number of sheets of paper. Okay, that's not how you do the half range method. What you do for the half range method is you do the half range method for each individual data point. So for example, what it should look like is it should be more like 51 or 55.1 minus 54.6 divided by 2. Okay, so this highest value minus this highest value divided by 2, and that gives you the uncertainty for that x value. And then you should go to the next column. You should do 53.4 minus 49.6 divided by 2. Okay, and then you keep going. And so what I'm saying is each row is going to have a different uncertainty if you use the half range method. Now, does that mean you have to um, actually write down the uncertainty for each individual one? No. Notice that here they did plus or minus 2 centimeters. So the way they got that was basically they did the half range method for each of these 1, 2, 3, 4, 5 data points. They found which one was the biggest. They saw it was plus or minus 2, and they just used that as the uncertainty for everything. Okay, so they use the biggest possible uncertainty because you always want to overestimate the uncertainty rather than underestimate the uncertainty. Okay, and so there's a difference between the uncertainty in your individual data points and the uncertainty in your average value. I also want to point out that they made a mistake here because this uncertainty should only have one sig fig, first of all. And second of all, they have one decimal place here, but there's no decimal places in these average values. And so really it should probably be plus or minus 2 centimeters, not 2.0, because otherwise it's got too many sig figs and the number of decimal places doesn't match. Okay, so pause it there, rewind if you have to, make sure you understand how that's supposed to be formatted. Okay, and so I also want to point out, let's see, I think I included all of this. Make sure the decimal places are correct. Make sure the data looks all nice. Make sure you only put the units in the heading to make it easier to read. Make sure everything is aligned correctly. Everything has the units. You have uncertainties on everything. I said this before, but as far as determining the uncertainty, it says here there are two ways you can determine the uncertainty in an experiment, both of which should be accepted by the IB. Okay, again, using the uncertainty in the measuring device and using a reasonable judgment call of what you think the uncertainty should be based off of how confident you personally feel about the uncertainty. And so please don't email me saying like, should I use this uncertainty? Make a judgment call. Justify the judgment call. Even if it's not one I would agree with, if it is something reasonable, then the IB should accept it as long as you explain like this is why I chose this uncertainty. You only use the half range method to find the uncertainty in the average values. Okay, so let's see, this is just talking about the half range method. When you go to make the graph, your graph needs to include error bars. And so an error bar is basically a visualization of uncertainty. Okay, and so error bar basically looks like what you see here with these little lines. So it looks, if you were to draw it, an error bar would look something like that. And so it's literally representing like on the graph the range of values. Okay, so in other words, if the uncertainty is supposed to be plus or minus 2, then each of these dots is the data point, and then it goes up 2 and then down 2. Okay, that way you can visually see how uncertain each data point is. Okay, now there's a way to do error bars um, in Excel or Google Sheets that we can talk about later. All right, but your graph needs to include error bars. I also want to tell you that when you make your graph, you should make sure that you label the name of the graph. You should label what's on the y-axis and the x-axis along with the units on both. You need to make sure you include error bars, like you see here, and you need to make sure you include a best fit line. We'll talk about that later. Um, and if the graph is already linear, then in addition to the best fit line, you need to include the equation of that line. And I can show you how to do that in Excel or Google Sheets. It's pretty straightforward. Now, if you graph your data and the data is not linear, then you will have to linearize your data. And so that's what we'll talk about in the next video. Something else that's really important that I want to talk about is what type of graph you should have. Okay, so listen carefully. Your graph should be a scatter plot. In other words, you should be able to see the individual data points without anything in connecting them. Here's what not to do. Do not use a line graph or a bar graph. Okay, do not use either of those graphs. A bar graph is not appropriate for a scientific investigation of this type. A line graph is also not appropriate because a line graph will basically connect the dots with your data points. Do not do a line graph. Do a scatter graph. If you do a line graph, that's the fastest way to lose points under analysis. Okay, so please do not do that. Okay, so make sure it's a scatter graph. Make sure there's error bars. Make sure that the graph is labeled. It has a title, etc. Okay, this is basically what your graph should look like. Okay, it's very possible that you will have more than one graph unless you're lucky and your graph comes out to be linear the first time. Okay, so again, we need to talk about what if your data is not linear, then what you're going to do is you're going to do something called linearization, which is basically a way of regraphing the same data to make it linear. And we're not going to talk about that in this video. We will talk about that in a subsequent video. Okay, and so I'm going to go ahead and stop it there. Um, the slides I'm showing you, by the way, these are in the IA criteria presentation that's posted in Canvas. So I would highly recommend you go through that entire PowerPoint presentation because there's some good information in there that should give you an indication of what things should look like and what elements you need to make sure you include. Okay, so in the next video, I'm going to talk about how do you actually make graphs in Google Sheets or Excel, how to include error bars, and then I'm also going to talk about data processing and linearization, which is probably the most complex thing that you need to be able to do for your IA. Okay, so as always, please let me know if you have any questions, and I'll see you guys in the next video.